what I could do, let's say somebody's hacking it or something, and the hacker's coming from the IP address of, let's say 222.100. So let's say that's where the hacker is here, and his IP address is 222.222.1. Sorry, .100 actually. I select this text here. All right, let me just put 00 on the end. It's not letting me select that text for some reason or other. That's 100 there. So if that's where the attack is being sourced from, well, what I could do is I have a few options here. What I could do is I could filter the traffic so that it can't reach, so that it cannot reach the destination. But that's not going to be a good solution, because if I use that solution, if I use that solution, well, what's going to happen is nobody else is going to be able to reach that destination. If I filter the traffic as it goes out, the problem is if I filter traffic as it goes out, it's going to already go to the server, and then I'm going to hit it as it goes out the router here again. So as it goes back out the router, I could filter it here. But that's not the, that's not the best solution. The best solution would be able to hit it in the beginning. I could hit it in the beginning by putting an access list on, like right here, or an access list on here that says, okay, traffic from this source to this destination. But that's really a pain in the butt to put an access list on all the time. So what I'll do is I'll just put a route to null 0 for that source, and then what's going to happen in enable unicast reverse path forwarding. So then what's going to happen is when the packet first comes in, unicast reverse path forwarding says to check the source on this here. The source is the null 0, so it drops it when it first comes in. So it's like filtering without filtering, just by doing the unicast reverse path forwarding filtering and the static route, we drop this traffic. So it doesn't require complex access list entries. If a server is under attack, you just drop into the router, put a route to null 0 for the source, and then it's dropped. All right. So the syntax here for the command, the two different modes here. Oh, as a side note, required for Ceph. Ceph is required for this feature here, I should say. Two modes. Strict mode here. The command syntax a little bit different. IP verify, unicast reverse path. That means you must be coming, their traffic must come in the interface I would route to get to that source. Okay, I could have multiple routes to it, and then any of those interfaces are valid. The loose mode says I must have a route to you somewhere in the routing table other than null. Okay, if it's rather than null, you get dropped. This is the most common option that you see, because if you don't have routes to the RFC 1918 addresses, those packets are dropped. If you want to black hole some traffic, you just put a route to null 0. As soon as that traffic comes in with that source, it gets dropped. Any dark networks that aren't being, or actually I should say, mostly the term is dark IP addresses that aren't really allocated out there, then let's say if you've got a whole bunch of /24s that aren't being used, if you don't have routes for those in your table, but yet your /29 or your /20 advertises those to the internet, as soon as that packet comes in, gets dropped. All right, a lot of times what people do in that case, let's say if they have a /29, but yet there's some /24s or something that's not being used of that. Sorry, not /29, but /19. So if you have a /19 or a /20, and then you have a lot of these /24s that you are not using, what you can do is on your edge router that has this feature configured, just ensure that it doesn't have a route to these /24s, and then it's going to drop it. What some people do, though, is they create these dark IP addresses, and essentially they have a machine that's got every IP address that isn't used is addressed on one machine. Then they just, it's like a sinkhole. They suck up all this traffic. So all this traffic gets sucked up. Another thing they do commonly on the edge is they'll just route this traffic for these unused networks to null zero. Just drop it right there. All right. But if you just enable this feature and you don't have a route, it gets dropped. Okay, so those are the two modes here. The one we're going to see again here coming up here is we're going to see loose. Okay, we're going to see loose because we're going to use it for some advanced filtering techniques. Okay, commonly disabled services we normally disable, okay, for ISPs. Finger, BootP, you may see some other ones like TCP small servers, UDP small servers, those are disabled. You may see one called PAD, which is X.25. You can actually communicate, you can actually manage a router through X.25, meaning that you can connect to the router remotely using this X.25 address. The command no service pad in the global config, which is the default now, that disables that functionality. No IP BootP server, of course the standard CDP stuff, proxy ARP, redirects, pretty standard. No IP directed broadcast, that is the default. I'll mention real quick, I'll talk real quickly about what a Smurf attack is and how it relates to this command here, but it's probably the most overblown attack that you see. And it's, I don't know, it's like every practice lab you ever see has got something, it's got, any security one has got something to do with Smurf attack, but we'll talk about it here. No IP unreachables under the interface. Okay, it's changing, it's saying do not send ICMP type 3 destination unreachables. Also, the router by default rate limits these. It'll send 1 per 500 milliseconds. That's like sometimes when you do trace route. Trace route, and you get these, you get these stars in the path because maybe this destination isn't reachable there. You can also do a ping to an IP address that the network is advertising for, an IP address in a network that router is advertising, but yet the IP address isn't actually assigned. That would be another way to test this here. These type 3 unreachables here. So it's quite common to rate limit these. The iOS rate limits these by default. Why? Because if not, the router will become the target of a denial of service attack. You just send, a bunch of packets to destinations that are not really assigned, and the router's got to generate all these. This person's got to try to ARP for it. Then it can't ARP for. Then there's no reply. Then it sends back these unreachables, and then you create a DOS attack to the router itself. And that's essentially what happened. I don't know if you guys remember back in about 1997 time frame, back when the day when people would DOS Yahoo or E-Trade, they would DOS these major websites. Then they eventually fixed it. The next step they went after is they DOSed the routers. The routers were the ones going down. The way, like E-Trade, the way they dealt with these DOS attacks, they just put bigger and more servers up. It's so many. There's so many servers distributed around different locations. There's so many of them, and they're so powerful. You just cannot overtake them. It doesn't matter. You can overtake a small site these days, but you can't overtake like Yahoo. They just put more servers up, different locations, and I thought that was actually kind of interesting. I thought, I thought there would be some really cool technique they were using. No, it was just so many servers that were so powerful that you just couldn't take them down. Then what they started doing, people trying to do the DOS attacks, they started hitting the Cisco routers in front of them. All right. Luckily, though, that didn't make it to the, some of these times when these outages happen in the late 90s, 97, 98 time frame, sometimes these outages happen, it wasn't Yahoo going down. They attacked the Cisco router in front of it and then essentially brought it down. Okay, so the router, like I said, this is on by default, defaults to 500 milliseconds. You can change that behavior there. Quite common to change it in an ISP environment. Maybe let it send one every, 3 seconds. 500 milliseconds is one every half a second, and that's the default value here. But it relates to these, no IP unreachables. If you're routing a packet to null zero, normally you put no IP unreachables under the null zero interface. Okay. Real quickly, talk about a Smurf attack here. Basically, what you're doing is you're sending a ping to the directed broadcast IP address. Your source is the source